Hey, what's going on? It's early in the morning here for me. I'm about to start studying real analysis because that's the best time to study, is right when you awake. I'm gonna get some tea first, though. All right. Let's get it going. Matthias. How's it going? I'm gonna get water too. I just woke up, so my voice is kind of hoarse. Croaky as shit. You know how it go. Okay. Yeah. Alrighty. Second pronunciation is correct. Okay. Breva. Andre. How's it going, guys? You all studying too? Yeah, good morning, Reza. So I think I'm probably gonna study for like an hour or two, and then like eat some lentils, and then keep studying. Alrighty. So I'll pull up my exam review. I should really like have this page bookmarked, honestly, by this point. The amount of times I've come back to this. Content and activities. So midterm list and midterm example. I'm just gonna pin. How do you pin tab? Pin tab. Are there any Europeans here? I study math too. Linear algebra, second semester. Linear algebra can get tough. That's no small feat. Climbing shoe Rex. I'm not the biggest climber in the world, honestly. I have some climbing shoes, but this is my climbing shoe model, if it means anything to you. And Unparalleled, I guess, is the brand. The reason I have these climbing shoes, which are fairly nice, is like, I'm a student athlete, and there's this website called Expert Voice, and if you get on this, you can get some really insane deals on gear. Hey, what's up, everyone from different Norwegian countries? Glad to have you. All right. There's a lot of, so for people that are here to watch me study specifically instead of study your own thing, the problem I have right now is this feels like a little bit janky what my professor has given me. My exam's tomorrow. So she gave me this facsimile exam, and it's got 5 questions that are all like pretty easy, I would say, like pretty manageable analysis questions. And then she gave me this prep midterm list, which I think is either a bit older or just, I don't know, something's off about it because the questions are all significantly harder than this one. And some of them are like just stuff we straight up have not learned. And yeah, so I'm not sure about that one. Use the integral test to determine whether this sequence converges, like, or series. Yeah, we have not learned the integral test. But there are some questions in this that I think are good and that will help me build comprehension. Like, I'd like to drill some open-closed definition, probably. Is this the Helium browser? No, this is just modded out Firefox. There's a way to take the macOS headlights off of Firefox. You can see right up here in the corner, it's like, I just turned on this feature that outlines application windows because I think it looks kind of cool. I'm back to ricing stuff. That's how you know things are going well. But yeah, it doesn't fully line up. Yeah, curriculum probably changes over time. You are right. So yeah, I guess I'm gonna start doing open-closed problems. Okay. yeah, I guess let's keep track of the time too. Useful binding. I should probably make a video out of this entirely, but I actually don't know how useful it is, but I have a couple of keybinds set up. Oops. Control R D for the date and Control R T for the time. The reason Control R is the prefix is because it's like register based. And I don't know, it's occasionally useful. Keep track of random things. All right. Problem 11, 12, 13, 14, 15 are all like good open closed. Yeah. Just let's do problem 11. Problem 1.1, my regex is fucked up. Oh, actually, it should be /d any number of times. There we go. Which is showing what? Closedness? Oh, show that it has a lower bound but no upper bound. And that inf s equals 1. Okay, this is pretty easy, like definitional stuff, I guess. Show that S2 has a lower bound but no upper bound. So I mean, take 1 to be the lower bound. Assume towards, well, the argument for the upper bound is pretty easy. It's just like assume towards a contradiction that like M is the largest, or is the is an upper bound. And you could say by the Archimedean property, but it might be like a little bit overkill. Oh my god, how do you spell Archimedean? I'm just saying our AP for now. Exists and m plus 1 greater than m. Okay. Which is a contradiction, I guess. Well, it's not necessarily a contradiction in the language I've defined it, but that, I think, in essence, is the argument for saying that something doesn't have a lower bound. And one is a lower bound because 1 is less than every element in the set. Bound since one less than but then part B, oh, and justify the infimum of S2 equals 1. Which just means there is nothing greater than 1. Well, okay, so I mean, if n greater than inf S2 equals 1, then n in S2 and is not a lower bound. Oh, Archimedean property is about natural numbers, not necessarily about a natural number. Thanks. Yeah. That's good. That's good, guys. Hey, Big Pepe. Good to have you here. Yes. Yeah, University of Vermont. And this doesn't look too bad compared to the real analysis exam I had to take back in the day, back in my day. No, but I'm sure you're right. I think I personally think there's been difficulty deflation in classes, which I think I'm a victim of to some extent, but I'm also responsible for my own destiny, so you know, I could be at Cambridge right now. Bachelor is 4 years in Canada as well. Vermont is not in Canada, dog. If you want to know, this is where I live. This small town. It's a really nice. This is a good view of it. Like my school. See if there's a view of the school. It's Olive Church Street. I mean, yeah, you can see we're near a lake. But it's winter right now, so it looks maybe more like this. And there's this lake out here. It's a really nice little town. I do quite enjoy living here. Oh, as well as the US. Yeah, I'll come to Europe at some point. I'll do a European tour. Yeah, Bernie does live here. That's true. Okay. And then part B, determine whether S is closed, open, or neither. Okay, well, I would say that S is... So let's see, it's not closed. 1 is a limit point, because we could take like 1 over n as our sequence. Now, is it open? I would tend to say yes, it's open, because yeah, for any element you could draw an epsilon ball, because it's so like R is open, and just because like R goes on forever, and 1, yeah, I think this is open. But how do I say that rigorously? I mean, like, let's see. I guess using the definition. Open since for arbitrary x in S2, an epsilon neighborhood of x subset S2 we have an epsilon neighborhood of x sub S2 such that, well, do I have to fully prove out that subset, all the elements of S are in X, or all the elements of the epsilon neighborhood. I guess we do. That's literally how the proof goes. You have to pick a... Are Indians not allowed to watch the stream? Get the fuck out of here. That would be wild. Okay, but... What's up, Trial? Are you Indian? No, Indians are allowed. I have no problem with you if you're Indian. That would be weird. Okay, so... It's open. Well, if it's open, what epsilon value can we choose? By choosing, I think it's going to be like epsilon equals the minimum of x minus 1, or no, 1 minus x and x, because it's like unbounded on that side. Could that be right? So let's see. If we pick x like very close to 1, like 1.01, what's going to be smaller? The absolute value of 1 minus 1.01? No, that'll be smaller. That's incorrect. Or 1.01. Oh, well, okay, no, we need the epsilon ball to bridge the gap between them. So maybe that is correct. So if x is 1.01, then the minimum here is going to be 0.01. And we'll have an epsilon that is fully contained. That seems right. My PDF reader videos, I appreciate that. More tech videos are coming. Shouldn't need to use min here, because this will always be less than that. 1 minus x will always be less than... So what if we choose like 5? Then our epsilon ball is going to be 4. Yeah, that works out. Okay, and since it's less than epsilon, it's fine that it's like right on the edge. Why do you want to change to math, Austin? I feel like comp sci is also a really good degree, to be honest. Problem 12. It's also fine just to divide by 2 just to be safe. That's a good call. Thank you, Sammy. Sam Rian. You hit some interesting names. Korea Bro's still up. 108, 110 by the property, by what property? 108, 110. Oh, this was Archimedean property, but that's unnecessary. I guess this, okay, this one right here, I don't know if I'm the most assured about, because is that like a correct way to say that like M is an upper bound? This is technically, like, I think in the terminology, like, not a contradiction, like, because you can have multiple upper bounds. Like, I'm almost tempted to say is assume that, like, M is the supremum of S2, but the reason I didn't say that is I'm wondering, like, is there some kind of condition for the supremum to exist? Is there some kind of, like, least upper bound? Yeah. I love how every time stream chat becomes career advice, it's shitty also. Yeah, I also don't buy into the AI hype, man. that'll get you killed. Because first of all, I think it's less true than it feels. But also, like, if it is true, like, man, at least be one of the ones, like, doing kind of interesting shit with your life. Like, don't piss it away trying to optimize how you make money by, like, ass-kissing the correct fake work people. Like, just do like, math is fundamental to the universe. Just understand it for its own sake. Well, you can brush up on analysis with me. To be more pedantic, at 108, 109, perfect, just what I'm looking for. Something like, take M, assume M is an upper bound by definition of the set. M is greater than 1. Then M plus 1 is greater than 1, plus 1 equals 2 is greater than 1. Hence, M plus 1 is also from the set, and M plus 1 is greater than M. I'm being overly pedantic maybe, but at this stage you should be, I guess. Thank you, Dust. Something like, take M, assume that M is an upper bound. Assume its upper bound by definition of the set, M is greater than 1. Then M plus 1 is 2. Or is greater than 1 plus 1 equals 2. Hence, M plus 1 is also from the set, and M plus 1 is greater than M. Oh, you have to show that M plus 1 belongs to the set, is the key piece. And so that's like an and, but if you say consider M plus 1 since M plus 1 is greater than 1, it's in the set, and M plus 1 is greater than M. Yeah. Awesome. You can assume M to be the upper bound and show that there always exists M plus 1, which belongs to the set. The belongs to the set is key. Dude, sometimes I'm just like overjoyed by the fact that like I have a math stream with like a fairly difficult math class, and there's just like like 4 or 5 people that know this math well enough to give me homework help on it. Like that's just so awesome. And like at any time of the day too. You guys have no idea what like a tremendous advantage that is. And like just another person who's like following along with analysis. That's amazing, man. Does it have to be contradiction? Is it not admissible to say let x and S2, then x plus 1 and S2 2 since it's greater than 1, in which case there's no upper bound? Yeah, I guess, yeah, a contradiction is awkward. And this supremum of S. I think that's all we need. Ultimate tutoring cheat code? Yeah, for real. I mean, it's like I don't know. It's also just awesome. There are just so many people willing to like do math. People still scour. Most people still scour. Well, actually, the new thing, dude, is people using AI. But I just find the human element like I don't know, better. And also like AI occasionally can make a mistake on some definitional thing, and if it does that, like you have no way of knowing, which for math could be devastating. And I also just don't want to like I don't like it. I don't want to build I know jack shit about this topic, but I very much enjoy your presence. Oh, that's very nice. How hard is analysis compared to Calc 2? I would say it's a good, significant bit harder. Like, I didn't try nearly this hard in Calc 2. Depends probably on the analysis class and, like, what type of math you're good at, but... Alright. Well, wait. Advik Gupta. You should assume M to be the upper bound and show that M plus 1 belongs to the set, so by contradiction there is no upper bound. But, like, can't a set have multiple upper bounds? That's, like, why I was confused about that. You know, like, if your set, say your set is, like the singleton of 1, like, you have 2 and 3 as an upper bound, you're saying, like, okay, assume 2 is, like, I guess it's different. I guess it's different because this just has 1. I thought, though, you could have multiple upper bounds, but I guess it's by showing that it's in the set. I don't know. I think I got that one pretty much down. Okay. Let's do problem 12. The open unit disk. Proving that the open unit disk is open in R squared. Prove directly from the definition. I'm going to prove that the complement is closed. Ha ha. Only thing I'd say at 108. Thanks for using the line numbers. A surprising amount of people don't realize that's the literal point of that feature in Vim. Like, people think that in Vim, You use the line numbers to jump to lines. Ain't nobody doing that inefficient, slow shit. This is exactly for pair programming. This is so you can be line 108. Dust knows what's up. Like, that's literally why they have that feature. I'm convinced. And honestly, also, like, relative number. So if you want to scroll, that's cool. But I was, like, pair programming with this mentor. Oops, set no read-only, set no relative number. Yeah, it was pair programming with this guy, and we just kept running into issues where he'd be like, yeah, it's 5 lines above, but it's way easier to say line 108. I'm not a relative lines fan at all anymore. Because it's way... So, okay, I got to get back to doing this homework and stuff, nerding out about Vim, but... Like, say you want to go, I don't know, 5 lines down. You hit 5J. Like, that's just not the same. It doesn't hit the same as the other ways you can move in Vim. So Control D and U are better, and then HML, high, medium, low. That's also nice to split the thirds of the screen like that. I'm a big fan of that. And if you have scroll off set, like scroll off equals like 4 or something. High, medium, and low, you can see they'll take you to different points in the document, which I just turned off because I like the predictability. Like, it's a little harder for me to be like, okay, so hitting high, I'll end up 4 lines from the bottom, and hitting low, I'll end up, well, in this case, still at the bottom, but if I were higher up in the document. So I will do that, or I'll just like search directly for what I want and then use M to jump to it. And I find that's just way better than being like, okay, it's on line 15. All right, I'm going to type in 15J, and you know, I don't know. It just doesn't feel as good. So I think going to absolute line numbers just for like collaboration purposes is the more optimal thing to do. My take, though, I guess there's also 2 ways of doing this. Take the def of upper bound, and either one show that there are no element that satisfies it, or 2 show that the assumption, show that assuming that there is such implies a contradiction. Yeah, that's a good way to look at the problem, honestly, Sherlock. I'm gonna save that. There are certain comments people leave me that I know, like, just reading them later, I'm gonna be like, yeah, that guy was onto something. What's up with the... You know this is like a serious chatter when he's got clauses with numbers. That's a good piece of wisdom, of way to look at that. Okay. Let's see. Open unit disk. Sherlock is doing the name justice, yeah. Okay. Open unit disk. By the definition of open, prove directly, okay, I haven't even gotten done writing this damn question down. Prove directly that A is open and R squared, B is F bounded. Justify. Wait, is F bounded? What the fuck? Oh, I was reading the wrong question. Prove directly from the definition of A. I always do that. I always read the wrong question. Prove that... What is that symbol? It's, is it like a lowercase delta? Yeah. Delta A... the boundary. And A, how do we do that? Bar A. Closure of A. Oh, I just find. Just have to find. Find the boundary of A and the closure of A. I kind of want to, I'm on problem 12. It's a little bit covered. Okay, I kind of want to do this one first for some reason. I just had a hankering. I feel like delta A probably just equals the set of points x, y in R squared such that x squared plus y squared equals 1. And then the closure, I would assume the closure so what is bar? Is it math.bar? I kind of want a new variable for closure if I'm going to be using it. Closure bar. No. The function bar. Math.bar. No. Okay, so that's the wrong function. That's not what I want. I want like the above bar. Overline, there it is. So instead of bar, overline. Oh, yeah. Or closure, as I now call it. And I think the closure would just be that. Yeah, dude, Sioyek, however the fuck you say that shit, is fire. I love that app. That's like peak academia where. Prove that A is open in R squared. Okay, so it's open. So for arbitrary x in A, want to show that there exists epsilon such that epsilon neighborhood of x subset A. So what are we going to do for that? The distance formula we're working with is just x squared plus y squared. And we want that to be less than 1. So we probably want an epsilon in terms of x and y. So let's try to, so like x squared plus y squared is less than epsilon. So what's the best fucking way to do this? Is there a way to factor this bad boy? Or, well, no, am I thinking about this right? Okay, so that there exists an epsilon there exists an epsilon ball such that No. Such that the distance from the edge is less than the epsilon. Fucking. Okay, let me think about this. So we want to show that every point has an epsilon ball that's contained within the set. So we need to show that the point has just room around it so that we can fit some kind of epsilon ball in there. And the epsilon ball we're going to fit in there is like the distance of the current point to the edge over 2, maybe. And so what is that exactly? So I mean, we literally have it. It's this. Well, I guess like it's technically like square root that. So like, well, no. The distance to the edge. Not exactly, okay. Show that any point xy in the unit disk where x squared plus y squared is less than 1, there exists a neighborhood V entirely within. For part B, the boundary is the unit circle. Sure. These points separate the interior from the exterior. The closure is A is simply the union, yeah. The union of sets and its boundary result in the closed disk defined by... Okay, well that's not super helpful. It's just the answer. Except not going into the detail that I needed to in the first part. But, okay, let me think about this. I have to get through this. So, basically we're going to want our epsilon neighborhood. In other words, like, to think about it, well, okay, I think what's misleading me maybe is we have an epsilon neighborhood around an xy. And so if we basically, what we want to say is, like, going in both directions, I guess. So, like, we want an xy, let's see, plus, like, epsilon, and then, like, an xy minus epsilon. And we want both of those points to be contained within our set A. So we want we have those two things, right? And we want this to be this quantity to be less than our boundary, which is 1, and we want the other quantity that to also just be less than 1, I guess. Like, if it's 0, that's fine. Like, we're not bounded there. So, like, I mean, let's see, what could I pick? Could I pick x plus epsilon over 2, y plus epsilon over 2? So x, y are both going to be less than 1. If I add like 1 minus x to x, one minus x to x, the x's would cancel. But then we're left with 1 is not less than or equal to 1, so that doesn't really work. Assume a point of the disk, then x0 squared plus y0 squared is less than 1. Take a small ball with the center at x0, y0 that is less than epsilon. We now need to show that for any xy in this ball, we have x squared plus y squared is less than 1. A circle x with radius equal to the distance of x to dA should be contained in A. Midterm is tomorrow. Assume the point in the disk x1, well, xy. So, yeah, this is, okay, an arbitrary xy in A. I gotta be able to do this. So, now x squared plus y squared less than 1. And we have to find x squared plus y squared less than epsilon such that x squared plus y squared is less than 1. I mean, I'm confused. Can't we pick... Can't we pick 1? Can you literally pick 1? That can't be right. Picture would help, actually. Just try focusing on the gap. Okay. So our epsilon should be, let's say that our xy, can I do that? Or like AB, we have a point. So like if this is 0.5, then our epsilon is 0.5. If they're both 0.5, then our epsilon is what? Like, what is this distance? 0.5 squared. Well, so, okay. So I guess the distance from 0 would be the square root of these two squared. Distance from 1 would be, well, this distance is 1. It would be like 1 minus like a squared plus b squared. As a fraction. That can't be right. 1/2, can it? So there's two disks. The initial one, 0, 0, that satisfies x2, or x, oh, that message also got redacted. If you know that the radius has to be less than 1, label epsilon as 1 minus r, where r is the radius. Try focusing on the gap. If you know the radius has to be less than 1, label the epsilon as 1 minus r. Where r is the radius. Radius has to be less than 1 minus r. And what is r? What is the distance? Is this, isn't it? Could that be our epsilon? Like 1 minus x squared? Oh, this is cursed. I don't even know if this will render. Yeah, it won't. If that's 1 minus our r, see if that would work. So if this is 1 minus, well, the square root is confounding, honestly. I'm not sure if it's required fully. Would that choice of epsilon imply what we want it to? Yeah, proving the open unit disk is open. Second desk, right one is satisfies. And now pick a neighborhood within that epsilon. Yeah, Dean. Oh, welcome, Dean. Dean's a crazy math person. Oh my god. Glad to have you here. Radius only matters because it lets us know the epsilon is positive. Now pick a neighborhood within that epsilon. What do you mean by that exactly? Yeah, don't you work for like a corporation that like formalizes math? That's like such a crazy job. I want to learn lean someday. I might do like a lean learning stream because that seems like a very good tool to learn as time goes on. Alrighty. 1 minus the square root of those values. I mean, also, I'm not sure what you mean pick an epsilon neighborhood inside that, which is problematic. My intuition doesn't throw that immediately. But what about that as a choice for epsilon? I thought about that briefly. Like, would that get anything? I mean, like 0 is clearly less than 1. But we want this to imply x squared plus y squared is less than 1. I guess. Auto formalization. That is so awesome. What's it called? Like Math Corp? I don't know if that's it. That might be it. Well, let's pick some arbitrary point and then pick a second point y so that y minus a is less than epsilon. Okay, Math Inc. I do have to check this out. Math Inc. This is much more. Verified superintelligence via auto formalization. Damn, that's sick. And their careers page is just like a form. You know that's how they're legit. Yeah. Gauss on GitHub. This is a very nice website, whoever made this. This is your project, right? Riemann hypothesis for hypothetical curves. What a sick-ass job. That's awesome, man. Good for you. You should feel good about yourself. That's a good place to end up in life. You can take epsilon is less than 1 minus square root where x0 is the center of the disk. Okay, Dust, that does make sense to me. I don't know. Maybe I will apply. I feel like my math knowledge isn't where I want it to be yet. Maybe I'll apply like a summer from now, because I also, I want to be working on software stuff a lot this summer, but I'll think about it for sure. You see, guys, people think that recruiting happens over LinkedIn. No, recruiting happens over your YouTube homework stream. That's how you get jobs. You glaze people who who are more qualified than you are, and then they take pity on you. That's how you do it. You just got to show that you're interested and you've got initiative. Okay, using epsilon less than this for an arbitrary x0, y0, and pick a second point so that y minus a is less than epsilon. Why do you have to pick a second point? Pick some arbitrary point a and personally replacing AI with my shitty human math. Okay. For an arbitrary xy. The algebra part of these proofs is always the fucking hardest for me. I swear to God. So we have epsilon less than, we have x0, y0, it's less than epsilon. Why am I saying it's less than epsilon? What does that even mean? X0, y0 less than epsilon. So it's less than 1 minus square root minus x squared plus y squared. And so like I kind of see this, it's like this would be, if we get rid of this is like or we move this around, this is like saying this point plus, oh, these should all be squared. Squared. You know what I'm going to try to do is replace all S slash 0 slash 0 to the 2 globally. And replace that with a plus sign. Is Vim dead in 2026? You tell me. Plus, so that's like a point plus this other point is less than 1. You could just apply the triangle inequality. What you want to show is absolute value of y is less than 1. You're pretty much done. Any point xy in the second disk satisfies x0 minus x squared really helps to draw this out. Well, are you talking about draw it out geometrically? Because like I feel like I absolutely understand geometrically what's happening here. That like, so for this we can generate an epsilon ball with radius of like this distance, and then it'll be fully contained no matter how close we get. Like the geometry there, and so, and I understand, so this is like, here's our point. Its distance from 0 is x squared plus y squared, square root. And here's this distance from 0, it's 1. So we subtract this distance from 1, and then we get this distance. The geometric argument is cool, unless you mean draw it out algebraically. Like, I just struggle with like the technical mechanics of the algebra more so than anything at this point. Like, that's definitely my weakest point of analysis, is like the algebra more so than the intuition, I would say, but I don't know what you meant exactly. I guess you need to actually touch the distance formula for this. Yo, how's it going? Oh, what's up? It's really Zen. I feel like labeling each line segment with distance could help, though. It might be clearer when triangle inequality comes in. So when the triangle inequality comes in. Yeah, it might be. x0 minus x is less than r squared. This x0 minus x squared, y0 minus y squared is less than epsilon squared, comes from the equation of a circle. Okay, like, yeah, I like that. I like that a lot, but oh, you never need to actually touch the distance formula. Well, what Mithril's saying. I thought you said you do have to touch the distance formula. Just apply the triangle inequality to like where though? I don't see. So x0 minus x squared, y0 minus y squared, less than epsilon squared. Yeah, might be clearer where the triangle inequality comes in. If you come back to the y minus a is less than epsilon from earlier, that's just 2 points. Two points in the ball on the edge. And it suffices to show the difference between 2 points. Is less than epsilon. I'll read your other messages. You have to apply the triangle inequality, pretty much done. Pick some arbitrary point a and then pick a secondary point y so that y minus a is less than epsilon. I guess I'm unfamiliar with that definition or technique. Y minus a is epsilon, or it's just like a rearrangement of one I know. 2 points, the edge of the ball. So are you saying if we have A and N A minus N okay, impossible to explain in live stream comments. Dean, if you have a second, I'd hop on a voice chat. And epsilon is 1 minus radius. 2 points from the ball to edge because A is an arbitrary point. Who TF is that? It's 4:30 a.m. Yeah, no worries about that too. Let me see. I've done this problem multiple times. Like, I don't like to cheat myself of the algebraic understanding, but I have a good sense that in homework 3 we did this problem. The open unit ball in Euclidean distance. Oh, this was not done rigorously at all. I remember crashing out on this bad boy too. That's why. 1 minus x over 2. Now, I want to actually do the algebra. Okay, yeah, no worries, Dean. Yeah, the Discord link intentionally doesn't work. I have to actually remove that. It's a good thing you reminded me because people ask about it all the time. But Mithril, just send me an email and I'll let you in. I have to like change that in my YouTube settings. How do you do that? Like upload defaults. There we go. I guess I should show this, what I'm writing. So the Discord, I don't fucking need channel perks. I don't need that either. That's old. Write me a compelling email if you want to work together or join the Discord. Use proper punctuation. All right. There's the Discord link. Yeah. Oh, I'm just blatantly showing my revenue. I think that's against terms of service. Who gives a fuck? I love Sioyek. First learned calculus in junior year of high school, I guess. When I was 16 or 17, maybe. Pull up Excalibur. Well, I don't know, Mithril SB. What, like... Quick, report that. What was I saying? I don't know, man. So basically, my problem is like I can get 90% of the way there at this algebra, though. For some reason, it's like tripping me up. And you know what? If you've ever, if someone wants to drop the explanation for the algebra in a typed document, and if you want to try the typed project, we have a stream document we sometimes use. And I'll go ahead and share the link. Oh, we got a lot of people on this. So if you want to drop the algebraic solution in there with more, I don't know, rigor, or you can just write like much more notes and use math symbols and stuff, feel free to do that. I'm just gonna, for the sake of time, move on and then come back to this problem later. Because, like, I would get, I think, 9 out of 10 points on credit knowing my professor and how she grades for this, but yeah, I just want to be efficient with my studying time. Okay, problem 13. xy greater than 1, x is greater than 0. Prove that f is closed by showing its complement is open. Let's write down this set because it's a little weird. xy and r squared Do I have an alias for this? I think I do. Yeah, I do. R2. Yo, we got hella people up in this types document. Hopefully their servers can handle that. XCCXCXXCXCXCX. Okay. XY equal to 1. X greater than 0. Prove that X is closed in R2 by showing the complement is open, and then B is F bounded. Yeah, it's 12A. I can actually... make this document view only. But how are people going to type anything? Oh, I see. Yeah, that makes sense. I'm just gonna like mass kick everyone, I guess. That's an unfortunate conundrum. Never had to deal with that before. Whatever. I'll just come back to this later in the stream. I'm on voice chat with someone or something. It is 12A. What time is it for me? It's 7:30. Probably eat at like 8. And then just keep studying. Prove that F is closed at R2 by showing the complement is open. Okay, so the complement is going to be what? XY is less than 1 and X is less than 0. And X is less than or less than or equal to 0. That's the complement. F complement. I don't like that font. I still regret doing a bachelor's in math. Had to start. Yeah, what I would say about this is that if you're taking math is amazing if you can already code, or you have like an auxiliary employment backup so that you don't end up as a professor. Nothing wrong with being a professor, but it doesn't pay great. And it's also kind of like bad work in a lot of ways. Or you can end up as like I don't know, doing what Dean does. I'm a computer science and math double major technically, but So proving that the complement is open. Yeah, professor is a solid job. So if we have x1 and f. You know what's cool is we could actually call this a variable. We could call this f complement. So we don't have to retype it. Well, that's kind of annoying. That writes out the whole thing. Actually, that's not really what I wanted. What I wanted, I guess, is like this. FC equals that, and then down here I'll say like F to the C. Arbitrary x1 and fc. Want to show there's an epsilon neighborhood around x1, which is contained in f complement. This damn algebra is definitely the hardest part of analysis for me by far. I'm saving that. That's a I need like a best comments dot type. That's awesome. Oh my god, that is so perfectly encapsulating like the mood of what it's like to be in a community like this. Is with Europeans. Well, no, just because there are a lot of Europeans helping me usually, so I wanted to give them credit. But yeah, I guess subconsciously I wanted more aura. Okay, whatever, bro. That's just a really good comment, though. I appreciate that. Okay, I want to show... So for an arbitrary, we want to show that there exists... So we need an epsilon. I'm going to quickly just brush up on... where's my Syoyek? Syoyek looks so nice. Can we get rid of the title bar though? What's up, Vladimir? How do you prove a Cauchy sequence is bounded? Tail is bounded by triangle inequalities, so you don't have to worry about for boundedness. You are never cooked. Let's see. Open basic topology of the reals. So this isn't like a problem for me at all. I'm like very consistently applying this definition. It's just like the algebra beyond this is what's difficult for me consistently, of showing, like, finding that existing epsilon. Epsilon. Do I have to pull up my Greek keyboard? Epsilon. It's the wrong kind of epsilon. Like, yeah, just the mechanical algorithmic process of determining what actually needs to be done is tough for me. I have to drill that. Oh, sorry, I was muted AF. Okay, you should be a member now. I had to jump you over the gate. You shouldn't be allowed, like, this guy is not paying his way into the Discord. I'm giving him access because he's been here a while, and he's, like, a channel meme. So not that you're a meme in a bad way, you just, like, add spice and flavor to my streams by, like, offering to buy me an OnlyFans, or offering to buy my OnlyFans. And, like, I'm not gonna ever do that, but I appreciate you for making things interesting for other people. You've made it into the channel lore a little bit, so I think you deserve it. That might be a hella weird take, I don't know. Yeah, I mean, you're a recurring character, dude. Like, people ask me every once in a while, like, what happened with Vladimir? Did you take the deal? Like, you're talked about. So I want to see. Okay. Basically, does anyone have any advice for me? This is the... I wonder if I can, like, throw up, like, a question that could be solved. What is this first question? We solved these in kindergarten. Sadly, my education system is not as good as yours. This is Understanding Analysis by Stephen Abbott. But, okay. The question I want to know the answer to is, so I'm pretty good at, I can set up the definition very quickly, like, but what's the algorithmic process for determining, I mean, it's something I have to practice, obviously. I just have to practice it over and over again. But for consistently, like, determining your epsilon in a case like this, it's you consistently determine the value of I think I have to kind of break it into steps more so than I am. I'm treating it like too much of a black box process. And yeah, it's not fully ideal. Okay. Big Pepe. Yeah. How do you think about this? Like, how do you arrive at a specific value? You have to inject custom CSS into Firefox. There's like a whole Reddit community dedicated to doing that. I did it so long ago, I honestly don't remember how I do it, but you can get a style sheet. Wait, so the problem is this, is it's kind of a meta problem, Pepe, actually, but we're showing that this set is closed by showing the complement is open. But in general, like for openness problems, I'm struggling with this part of it. Like the definition of openness, I always correctly can set up. I more or less have the intuition for like what it means to have an open ball, but getting actual, like finding the epsilon algebraically consistently is what I struggle with. So I want to like, well, I guess you kind of almost guess at it. Yeah, that's the real challenge. I'm gonna go get my breakfast, but I'll be right back. Okay. I don't think there's a general algorithm that works for every problem. Okay. Straight up an epsilon NBHD. What's NBHD? So pictures help a lot in analysis. We would usually just sketch something on the board and then guess epsilon from the picture, and then an algebraic proof would become a technicality. If you struggle with formal definitions that apply differently to each problem, the best way to learn it is to accurately digest solutions and grasp some kind of intuition around the topic. Oh, neighborhood. No, it's straight up an epsilon neighborhood proof, I think. Although, that's a very clever way to do that, Dean, but yeah, I don't think they want us to. I don't think they want us to use continuity. Oh, computer architecture. That's a cool class. Let's see. But there's a couple of great chats that I have to still read. I want to save that too, actually. Pictures help a lot in analysis. I have to make more use of pictures. Trying to visualize is the best way to solve these problems whenever the visualizations are possible. Okay. I guess I should do that more. I can get my camera for drawing things going again. Helpful visualization to show openness is for every point we're trying to fit a ball centered at the point inside the set. Well, you see, like, I have that visualization down. Like that's exactly what I'm picturing when I'm doing this. But then it comes to, like, formalizing the algebra, and I'm like, okay, well, what actually is the distance algebraically, though? Oh yeah, what does everyone eat to be optimal? I'm on like a hyper optimizing what I consume kick. This is like longevity mix from that guy Brian Johnson, the like live forever guy. And then I'm eating I'm basically survive on like lentils and like Mediterranean vegetable mix. It's like saturated with olive oil. I don't want to like chew into this mic too aggressively though. So I'm gonna like mute between comments. Bro, you're corny. What are you talking about? You're way cornier than me. Break into cases where x equals 0, x less than 0. Beef and rice. Beef and rice is solid. I feel like chicken is the more optimal meat, though, if you're gonna eat meat. Complement definition is wrong, certainly. Forgot to change the and to an or. That's tough because it's like implicit. Digest beef better. I don't get the same with chicken, not sure why. I mean, yeah, that's like if your gut microbiome is just really attuned to beef, nothing wrong with that at all. Like people have survived. Chicken is for soy fanboys. Wait, Big Pepe? To show us that it's closed, you must show the limit of every convergent sequence lies inside the set. The problem is, like, they explicitly say that you have to show the complement is open. I would love to use that definition, but they don't want me to. Master's thesis from Germany. That's awesome. What's your discipline? Also, yeah, let's break it down into cases and draw it. I'm gonna do that in a moment. I'm gonna bust out the drawing materials because it seems necessary. Problem is really, really annoying if you don't have y is less than f of x is open for f is continuous. It's something I wouldn't expect you to do. Okay. No, somebody here for you're not invisible. It's just like everyone asks what math is this, and it's like in the stream title. I just get that question like 40 times a day. So I get kind of tired of answering it, but glad to have you here. Alright, I'm going to bust out some paper and draw this after I finish this. Well, I had to go at problem 12, but someone has written out that types document, and I don't want to get rid of their work. Yeah, it's really zen. If you create another types document and you create a read-only link and paste it in chat, that would be a good way to handle that. Oh my god. Alright, this is how I'm getting my camera to work. Prop up some ski poles. And we're good to go. I haven't took my phone off airplane mode in like 3 days. Oh shit, there's like hella notifications I gotta respond to, but okay, how do I add a source? Add video capture device. There we go. This is very fragile and finicky. Keep having to like snort like crazy because I'm sick. It's really annoying. Desmos for this problem? Yeah. Are you allowed to use Desmos in the exam? Hell no. I feel like I'd rather visualize this using our ancestors did not drink that stuff. Yeah, bro. I mean, it's true, but also, like, our ancestors were not bombarded with screens 24/7. Our ancestors did not have access to amphetamines. Our ancestors did not have problems in the modern world. And, like, while I understand that as a dietary thing, is, like, not bad advice whatsoever, it's also, like, I don't know, we could, that argument to me is weird because I don't know, like, did our ancestors have access to meat that was like lab, like that's been raised in a factory to be like maximally nutritious based on like a dietary constraints and stuff? Like the engineering of our food has already reached such like a frenzy. It's like, yeah, I don't know. And I'm like all for eating natural foods, you know. I'm eating lentils and shit up the wazoo, but modern times, modern problems. Like I believe in technology, including nutrition technology, even though it's not my field. I know it's come a long way. Okay. Sound gone. How How do I rotate this bad boy? There we go. Zoom in a little bit more. I want to keep myself in frame. And ideally also the textbook. Where's my pen? It's nice, but I don't get what my prof wants. Yeah, analysis is wicked hard, dude. Math is no joke. Can make you feel dumb very quickly. Keep reminding yourself that it's like it's really hard. You're now approaching very difficult math. And it's, I don't know, so if you see a lot of people, like grad students and stuff, they're like, oh yeah, that wasn't that bad for me, but for the average person, man, this is like, dude, like my mom or sister couldn't tell you what summation notation does. They couldn't tell you what, like, the sign does. Think about how many levels of abstraction you're built now. Like, it's, shit gets serious. Yeah, okay. How am I going to draw this? In the plane. So, if this is F, let's look at it like that. This is F complement. We have greater than 0 and x times y greater than 1. So x is going to be greater than 0. That rules out the bottom half of this. And x times y is greater than or equal to 1. So what is that going to look like? We've got to have one of these terms greater than 1 at least. So if like 1 is here and 1 is there, at least one of these terms has to be greater than 1. So like this is okay. No, both of these terms have to be greater than 1. Because like 0.5 times 1 isn't okay. So like, are we dealing with something like this? Modern algebra and topology and complex analysis. X is positive, then y is positive also because the product is positive, yes. Oh, you could have 10 and 0.5. And it works. So no. Oh, yeah. Yeah, you're right. 10 and 0.5. Drawing is for understanding the behavior of the set in problem 13. So it might be better to say yeah, so that's a good hint. You could have 10 0.5 which works too. So 10 and 0.5. Well, we know it's in these two quadrants. The ones are weird. We don't have... So it's going to be like some kind of curve relation between x and y. 1, 0 wouldn't work. So like, what's the relationship though that puts this under 1? It's like, or what's the relationship that gets something over 1? It's got to be like, if something is 0.5, what would get it over 1? Well, 2 would. If something's 0.3, what would get it over? Well, like 0. No. 0.3 is a weird one. But like 1/3, say that it's 1/3. What would make it greater than 1? Like 3 would. So it's kind of like the... Oh, I guess we could do this. We could get two equations in terms of x and y. So like x, y is greater than 1. So x is greater than 1 over y, and y is greater than 1 over x. So if y is greater than 1 over x, as x gets big, we'd have a curve that's like a thing like that. And x is greater than 1 over y. Is that consistent? X is greater than 1 over y. Think of what makes it equal to 1. That's the boundary. Think what it makes is equal to 1. That's the boundary. Can't divide simply by y since you can be negative as well. Yeah, that also isn't really yeah, I mean, what's the full text of A? Complement is open. Well, x is greater than 0, so y is greater than 0. So you can, but you're right to point that out. Yeah. You cannot be negative, though. We established that. Yeah, so we're up here. So y is like greater than negative x, or greater than 1 over x. So what would that look like? Like say we have 10, y is greater than 1. Say we have 100, y is greater than 100th. So as we go up in y, no, what the fuck? I'm geometrically confusing myself. What Big Pepe said. First draw the complement as a shaded region of the plane. Epsilon formula is not fun. You might be right, Dean. Loki, you probably you probably are. This test covers up to continuity, so yes, we're allowed to use continuity on it. It's just like it comes before, like the epsilon stuff comes a lot before continuity for us in the book, so. Okay, so you're saying draw the complement first. X less than or equal to 0. X minus y, or x times y less than 1. So we're in the bottom quadrants, and we've got or x times y is less than or equal to 1. I mean, so 1 over x is a curve that's like that. Remember the or, not the bottom, the left half. Oh, you're right. That would be y. Think about the graph as y is 1 over x. So x is less than or equal to 0. And xy in R2. And xy y is less than 1 over x, or x is less than 0. So, like, are we getting something like this? I guess this should be a dashed line. Would that mean our the normal version of this set is like just a complement? It's just like that, but yeah. Anything below the curve is also in the complement. Yes, yes, yes. Hell yeah. European minds buff for real. Without the line included, yeah. Okay, yeah, so to be clear, the complement is like, this would be dashed. I fucked up. But this is correct. If this is f, it's including the line. Okay, so now we want to show that the complement, the curve is not in the complement, so you should see why it's open. Yeah, I see why it's open. Like, very, that was good. That was very intuitive. And to redraw this, but better, it would be... And then we have, like... So, since it's open, obviously, or since it doesn't contain that, it's open. But what is the distance to that? I don't know. And this is where so geometrically it makes a lot of sense. But I want to think about, we need every epsilon ball. So this is what I think about when I think about epsilon balls. Like, so say that, like, we're going to zoom in on this. So the dashed line is going to be a lot bigger. But we're just like zooming in really close. And if we have a point, what we want is there to be an epsilon such that we can make like a ball like this of radius epsilon, such that like it's all within our area. Oh, I did not mute that time. I'm sorry, guys. Whatever. Whoever wanted to hear that heard it. So, but yeah, that's what I'm confused about. Like, that geometrically makes a lot of sense to me, and I might be able to get a good amount of credit by drawing that picture. You can think of distances as the infimum of a set to define it. Then just explain that anything inside the ball is also in the complement to finish the proof. Instead, you show that all the points of a ball are below the boundary. That's funny. Alrighty, let's... Ideally, I should have like two different, no. I should set up OBS so that there are different scenes, so I don't have to fucking do this every time, but that's a problem for the future. Plus, we can get like a cute little thing going here. Oh, look at this. It's artistic and shit. Wow. So creative. Break it down into two sets. You know it's or. Okay. That's a good call. That's a good call. That's clever. Okay. So let me just read and internalize. Finding distance to the graph would be too hard. Instead, you can show that all the points of a ball are below the boundary. Break it down into two sets. You know it's or, and you know that the union of open sets is open. It involves solving polynomials and doing derivatives. I kind of want to do that eventually. Not on this stream, but just to see what would be involved. I bet they want you to use the shortcut since 1 over x is continuous on x is greater than 0. Specifically, let S equal d xp. P is a point in the graph of 1 over x. For each point x in the complement of f, consider the infimum. Pre-image for each of the 2 sets. Okay, so open up the preview again. So we're going to have x less than or equal to 0. Union xy is less than 1. Well, I guess technically we'll have xy where x is less than or equal to 0. And we will show that an epsilon neighborhood. So in the first case, to get rid of we will. The first case, xy, x. Well, no, we need an epsilon neighborhood such that x is less than or equal to 0. Often these kinds of problems with epsilons are solved backwards. You first substitute whatever you have with epsilon into whatever inequality you have, and then you solve the inequality for epsilon. Okay, wait. You first substitute whatever you have with epsilon into whatever inequality you have. Let's see. Think about a pre-image. Distance is always positive. Oh yeah, I was looking for who you mentioned. Define a continuous function, then because it's continuous, you get the pre-image of an open set is open. I don't actually think you need to touch epsilons at all in this problem. You need to just solve it by applying some basic properties of sets. Define a continuous function, then because it's continuous, you get that the pre-image of an open set is open. Damn, dude, that's genius. Yeah, wicked. So you've got you need to touch epsilons at all. You can just solve it by applying some basic properties of sets. Define a continuous function, then because it's continuous, you get that the pre-image of an open set is open. That's using a more topological language, but the thing that I was referencing is saying that y less than f of x is open when f is continuous. I think that's the only way they'd expect you to solve this. Use continuity and intermediate value theorem to show different. We haven't covered intermediate value theorem yet, bro. Chill. But yeah, that is cool. Is open when f is continuous. Okay, what's our f here on x though? More topological language. Sketchbook for math. Yeah, I do. That's really clever. I think the case you have in point is a ball x plus epsilon, y plus epsilon. You need to come up with it. Write out the two cases first. Okay. Well, so the first case, we have this. In the second case, we have this. And so this one is, I get, is very obviously open. Using Dean's formula. This one, not so much because of the less than or equal to 0. That seems closed to me. It's a case where xy is less than 1. Define f of xy as xy. I mean, do you even have to do that? That's like basically just like restating for the sake of matching up with that definition. Like it seems like clear. That's basically just saying that we've got a yeah, I guess it's necessary. You need a function that's continuous from an open set. And okay, I get what you're saying now. Define a continuous function and the image of the function or the pre-image wait, I'm dumb, no, disregard that. It's not x less than or equal. It's strictly less than because neither x nor y can be 0. Exercise 4.4.11 in the textbook. Okay. Topological characterization of continuity. Let G be defined in R. If B is a subset of R, define the set G inverse B by G inverse B equals X in R, G and X in B. G be defined in all of R. If B is a subset of R, define the set G inverse by So that G is continuous if and only if G inverse is open whenever O is an open set. G be defined in all of R. Subset of R, define the set G. So that's the pre-image. The pre-image of B is X in R, G of X is in B. Okay. Show that G is continuous if and only if the pre-image of O is open whenever OR is an open set. Man, that's genius. That is crazy. And it works because it's an if and only if. So so you're like, yo, continuous function on this bad boy. Boom. But you need some function where you have the pre-image is open. Continuous function. You just need a continuous function. Then you can get the pre-image of that function is open. You play Minecraft Bedrock Edition. It's because in 10 years from now, you're going to be doing this same thing, kid. That's the pipeline we all go down. Basically, you can rewrite the original condition for the set as x is greater than or equals 0, so the complement is actually x is less than 0. Oh, the function is xy. Yeah, my bad. So, xy, and is that true about the complement? Did I write that down? X is greater than 1. Basically, you can rewrite the original condition for x is greater than or equal to 0, so the complement is actually x is less than 0 strictly. Did I? I'm not sure. Because you can't have x equals 0 in the original set, it's going to collapse the product to 0. Right. That's subtle, but I see what you're saying. Yeah. Clever, dude, clever. You just got to take into account so many things in math now. It's outrageous. The pre-image of this function is therefore an open set. And in this case, we can say define a continuous function G. What should it be? Takes xy and gives you x. Is that right? Best part about this is you can characterize continuity on on a bunch of weirder spaces. Gotta love math for just getting generaler and generaler. That works, yeah. Thank you, Mithril SB. Polynomial function, boom, boom, continuity. As long as you have a collection of sets, you can declare an open. Declare open called a topology that satisfies some conditions. You can talk about continuous functions. Case 2 is off. What's off about case 2? For unvariant functions only. Uninvariant. Okay, what's uninvariance? Oh, okay. Data that only involves one variable. Fucking shit, man. You serious? So what's the fix? Like, G can only take one argument. Wait, is it fine if it takes multiple arguments but throws them out? Or... You're right. I mean, according to this definition, you're right. This is a pretty important definition, though. I'm going to bookmark this. Fucking shit, my Sioyak. I hate when he crashes. Bookmark. Topological. Check this out. Fuzzy picker over bookmarks. That's so awesome. How do you jump back, though? I need a jump list. Back. Go to beginning, go to overview, portal, next item, previous item, set mark, go to mark, move left. Prev state. Okay, that's it, but that's... It's gotta be rebound to control O. It's a universal property. It holds for multiple variables as well. Yeah, but you're working on R2, so G has to be uninvariant. Can't use general topology. General G can be defined on Rn, and it holds for Rn plus 1. Just a laptop. I use a Mac Mini sometimes. The Mac Mini is like my media server. So is this a problem or not, guys? Dean seems to think so. Mithril seems to not. So xy equals 1 plus y equals 1 over x. What if we try f of x equals 1 over x? F of x equals 1 over x. But that's not continuous. Well, actually, maybe it isn't the domain that we care about. No, x could be 0 here. That's not a continuous function. It is for x greater than 0 factorial. But can't x be less than? Oh, I guess it doesn't matter as long as we can find a continuous function for a certain domain whose preimage is. I guess we're choosing the function, so we're fine to just set constraints like that. Provided x not equal to 0. Is the preimage of that the same thing? I'm like 99% sure you should be able to do this in the exam. It does seem much simpler, to be honest, to just choose variant functions. The real line is open. So it's a preimage. Basically, g of xy equals x works. I mean, but what if we're not allowed? Doesn't have to be injective. The preimage need not be a function. You're balding grim. Dude, that's brutal. I mean, well, first of all, I'm not. I think I just like have a very weird hairstyle. There's no history of balding in my family whatsoever, but that's just like, if there was, like, I have friends who are genuinely balding. I think I also have a large forehead, which makes people think I'm balding. But like, imagine if someone is generally balding and you just like join their stream and you're like, damn, you're balding. That's grim. You're just spreading negativity in the world, bro. Like, what's the point of doing all that? All right, let's go back. I think I got the meat out of that question. So, and the next part is, how do you, no, that's my question. Prove that f is bounded. Well, dude, so Tellier, I don't know how to say your name. Tellier, types is literally the result of skill issue of some German fellas. It's hard to even comprehend how cracked these guys are. Do you know how difficult it is to write a typesetting compiler? It is insane how many edge cases you have to deal with and how many annoying formats, and like people that work with things that compile PDFs are like such chads. The amount of rust these guys have written to make this thing work as fast as it does is just unreal. Well, I'm not going bald. F is not bounded, so you can't prove that. You just need to say whether it's bounded or not and why. I mean, yeah, it's not. Like, but how do you say that? Is it a similar thing where you're like, okay, well, xy plus 1 say the upper bound since m plus 1 is greater than m and m plus 1 is greater than 1, oh, it's a little more complicated than that maybe, because the upper bound is m equals some xy, and then say like we have m prime equals x plus 1 times y plus 1 greater than m, since m greater than m prime greater than m and m prime in F, there is no upper bound. Does that work? Can't use f of x equals 1 over x. You get a function from the plane to the real line. Guess you could take the pre-image of negative infinity to 1. Yeah, negative infinity to 1 under yeah. Pre-image of 1 over x on R isn't the real line, but it's still open since the singleton 0 is closed on its complement. Ah, right. Is preimage of 1 over x isn't the real line, but it's still open since the singleton 0 is closed and its complement is therefore open. That's so fucking smart, bro. Boltzmann ghost. Gives you the wrong preimage. Just project everything on the real line. Ignore the y coordinate. Is that chill? Are we okay there? Alright, I have to go to class pretty soon. And then after class, I'm going to study more real analysis. I'll be back later. Thanks for the help, everyone.